Okay, let's keep going. So, this is a unique question. A car moves due east 30 kilometers an hour for 45 minutes. First thing, recognize we have two different time units. So I've used my goalpost method to determine that 45 minutes is the same as 0.75 hours. And then you turn around and you move due west 40 kilometers an hour for 1 hour. And then it's asking what's the average velocity for the trip. Okay, so let's remind ourselves here. Velocity is equal to a change in position over a change in time. Okay, we know the time component, but we kind of need to figure out this overall distance that's happening so we can get this average. So if we were to rearrange this equation to solve for distance, I would say that t times by v is equal to delta x. And so I'm going to start with that. I have my 30 kilometers an hour, and I'm going to multiply that by my 0.75 hours. Okay, and so when I do that, oops, let's see, there we go, I get 22.5 meters. Okay, and then if I take my 40 kilometers an hour and I multiply that by 1 hour, well, then that'll be 40. I said meters, this should be kilometers because that's my distance unit there. Okay, so now that I know my distance, let's draw a picture to see what's happening here. So a car moves due east 30 kilometers an hour for 45 minutes. So if this is where we're starting, okay, we're going to move 22.5 kilometers east. Okay, so we went 22.5 kilometers east. Then we turn around and we move 40 kilometers an hour for 60 minutes, which we said was 40 kilometers. So there's our 40 kilometers. Okay, and so like what is our change in position? If this is my initial, and we're going to call that 0, then what would be my final? Well, it would be 40 minus that 22.5, and so that would be 17.5 kilometers. So we know our change in position, we know our change in time, so let's figure out this average velocity. So x final was 17.5 kilometers, x initial was 0, and then time final was 1 hour plus a 45, which was 0.75, so it was 1.75 hours minus the initial is 0. We just started off at time 0. Okay. So my average velocity is going to equal 17.5 kilometers divided by 1.75 hours. Okay. And then, so that would just be 10 kilometers an hour, and that was my average over the entire trip. Okay. All right, so let's look at a different example. Right now, we've been looking at position versus time graphs, position versus time, and making calculations from that. Now we're going to create a position versus time graph. Okay. So a curious ant travels with constant velocity from a position of plus 10 meters to a position of negative 15 meters in a time of 5 seconds. Okay, let's lay out what our calibration marks need to be. So if they were 2, I would have negative 2, 4, 6, 8, 10, 12. I could probably add another one there, so we could say 14. Okay, so let's call those 2, so that'll be 4, that'll be 8, and that'll be negative 4, negative 8. Okay, and then we need to cover a 5-second time span here. But then we're going to turn around and we're going to go another 6 seconds. So we need 11 in total. So let's see what we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's add one more to get our 11 there. Okay, so this will be 2, 4, 6, 8, 10. Okay. All right. Here's position. There's my origin of 0, and time's going to pass. So it says a curious ant with constant velocity travels with constant velocity from position 10 meters. Okay, so we have our positive 10 at time 0 to a position of negative 15. So that's negative 12, and so negative 15 is kind of right here. But it completes that in 5 seconds. So there's my 5-second mark. Okay, so we went from time 0 at a positive 10 down to a negative 15, and that happened within the time frame of 5 seconds. I should have brought a ruler with me. Let's see what I can use instead of a ruler. So I'm going to draw this position versus time. Okay, so that's the position that occurred over this time frame. So that's the first part. Now it instantaneously turns around and moves from my negative 15 position to a positive 3 with a constant velocity in a time of 6 seconds. Okay, so we start here, and then 6 seconds, so 1, 2, 3, 4, 5, 6 seconds, we're now at a positive 3. Kind of in that range. Okay, that was our position, positive 3 after 6 seconds, 6 more seconds. All right. Now let's confirm this. It says that we're moving with a constant velocity. And we know that the slope of a position versus time graph is our velocity. And so that's the slope of the line. So as I look at this, my slope, the slope of my line does not change, which means I had constant velocity. And same here. Now the slope is different. We have a different velocity, but it is still constant for that time frame. Okay, let me grab our next page here. Okay, so now we're going to do a different position versus time graph. So we have a chicken is trying to cross the road. The chicken starts at a position of negative 5 meters and then travels at a constant velocity to a positive 10 meters in 10 seconds. Okay, and then 10 seconds later, it turns and moves to the 15 meters, and it took 10 seconds. Man, let's look at this. So first, it's traveling this distance in a matter of 10 seconds, and then we wait 10 more seconds before it turns around and then moves for another 10 seconds. So we have 30 seconds in total. So if we did 3, 6, 9, 12, 14, 16, 18, 20, 22, 24, that wouldn't be enough. So let's see. So we know if we did in 4s, that'd work. So we have, man, let's do 5s actually, because we're dealing with these 10-second intervals, so it'll be easier to see that, because then we have 5, 10, 15, 20, 25, 30. It's not a good use of all my space, but let's work with that. Now we have negative 5 position, okay, and then positive 10, and then moves to the 15 meter 15-meter mark in a time of 10 seconds. Okay. All right, so let's call these calibration marks here. Let's call them 2-meter intervals. Okay, so we have 4, 8, 12. We're going to add another one up there. And then we're going to have -4, 8, 12. All right, let's look at this. A chicken starts at -5 meters. Okay, so we're starting at -5. Okay, and travels at a constant velocity to a +10 meter position. So we're going to move all the way to a +10 meter position, and this happens in 10 seconds. Okay, so here's my 10 seconds, and we're at a position of +10. Now, 10 seconds later, it turns around and moves. Okay, so 10 seconds later, meaning we were standing in the same position for 10 seconds. We stayed at our 10 meters for 10 seconds. So that means we're going to go from 10 to 20 here, and we stayed in the same position. Okay. Now notice the slope of that line would be 0. And that makes sense because if we're not moving, we can't have any velocity. And now we're going to turn and move to the 15-meter mark, positive 15-meter mark, in a time of 10 seconds. Okay, so we're going to go from here to there's 14, so 15's right there. That's going to happen in 10 seconds, so we're going to end on that 30-second mark. In that range. Okay. Now I want you to notice that from this information, we could solve for our velocities because it's just the slope of these lines, and we can get that from our information up here. Okay, so we did plot the chicken's motion, and indicates the ant. Now we're going to indicate the ant's velocity for each interval. So we want to know this one, and this one. Okay, so we're going to call this interval number 1, number 2, and number 3 here. Okay, let me just check on our time on. Okay, before we run out of time on this video recording, this is where I'm going to hit pause and I'm going to come back. So when we watch the next video, that's when we're going to determine the velocity of each of these sections. So try it on your own first and then come back and let's compare how your answers relate or how close they are to us working through it together on the video, okay? Alright guys, I will see you in the next video.